struck by this image. I'm sure you've seen it. It shows nearly all of Greenland's ice sheet melting.
Like so much water running off that it was washing out bridges and things, that they were runways.
We should all be very concerned. We should all be very concerned.
The Greenland ice sheet has experienced increased melting in recent years. The meltwater is likely to contribute substantially to rising sea levels and possible changes in ocean circulation. This could have a severe impact on the Netherlands.
It's extremely important that we understand the consequences of this meltwater on coastal sea levels.
Henk Dijkstra is one of the physical oceanographers that study how ocean circulation influences regional sea level.
It's a big dream of mine to simulate the ocean circulation and to study how this affects sea level at coasts all over the world. One of the challenges researchers often face in realizing their high ambitions is a technological barrier. We always want to do our research beyond the capabilities of current technology.
We met Henk in the beginning of 2012. He inspired us with his energy and his enthusiasm. So we asked him, what do you need to bring your research to a higher level?
Because this will look very different.
Our expertise will ensure that you can make optimal use of technology.
To determine accurate patterns of coastal sea level changes, we want to use the highest possible resolution in our ocean models. This will also be very beautiful to simulate also. You see them gathering. Even if we had the biggest supercomputer in the world all to ourselves, it would take us months to get these results. A lack of computing power has been an immense obstacle in my research.
2013 marks the beginning of an ambitious project. 5 organizations, EMAL, the Netherlands eScience Centre, SurfNet, SurfSara and Commit join forces to connect 4 of the world's top supercomputers. The Netherlands-based Cartesius is connected to Emerald in the UK, Supermuk in Germany and Stampede in the US. By connecting these supercomputers, Henk's team can perform more and bigger calculations and achieve a much higher resolution model of the ocean circulation.
By using these extremely fast long-distance networks called light paths and by taking advantage of new technologies such as GPU computing, we can vastly increase the amount of computing power we have available.
Running the ocean circulation model on this system is extraordinary and unique. No other project connects 4 supercomputers with light paths, transporting data at 10 gigabits per second. It requires the coordinated expertise of climate scientists, eScience engineers, and infrastructure specialists. It enables Henk Dijkstra and his team to undertake research which would otherwise not be possible.
When I first got in touch with the eScience Centre, the resolution of our ocean model was 100 by 100 kilometers. 2 years later, we simulated the ocean circulation at a resolution of 10 by 10 kilometers. We are now able to simulate sea level at a resolution of an amazing 2 by 2 kilometers. Warm water is coming southward here with the Agulhas current and is moving into the North Atlantic. It's amazing. Now I can see details which were impossible for me to see before. When I saw the visualizations of the high-resolution ocean models, it gave me goosebumps. For the first time ever, we saw the effects of ocean eddies on sea level.
Never before have global climate models achieved this extremely high resolution. It enables the team to make detailed simulations of the impact of Greenland's melting ice sheet on regional sea level.
It is great to experience the excitement and the passion that a scientist has for his research. And that's why we're here, to allow the scientist to focus on the research questions without considering the technology to be a barrier.
Thanks to the use of these high-resolution models, we are better at anticipating the future and to take precautions when necessary. Like how high we have to build the dikes along the Dutch coast to prevent disaster, and at the end, to save lives.
We are here to work with scientists like Henk to allow them to achieve scientific breakthroughs.
Henk Dijkstra and his team have come one step closer to determining the impact of future sea level changes on vulnerable coastal areas all over the world. But it's not just Henk and his team. In fact, scientists all over the world can benefit from what we call enhanced science, where collaborating international teams overcome technological barriers and achieve scientific breakthroughs.